Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 96 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons, and in this class we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life will be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. What I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 95. But I must start by asking how many of you were successful. If you were able to do this on your own, leave a comment down below. I am legend. Double chest bump. And if you are not able to do it, leave a comment down below. I folded up like a cheap Walmart lawn chair. I sometimes think I should add a third category, which is I never even entered the arena. Okay, but hopefully most of you guys at least tried it, and hopefully you guys got at least close to it, but it was a little bit of a tough problem. And in fact, I had issued this 3 or 4 weeks ago as a grand challenge. I had issued it as a grand challenge during a live stream to see if anybody could do this before I sort of stepped you along in baby steps over the last three or four lessons. And we actually had 2 winners. The first solution I saw was from Quaternion, and he came up with a very quick and a very elegant solution to the problem. A few hours later, I saw Charlotte's solution post, but I think she had actually maybe done it a little bit before Quaternion, but it just took her, her comment didn't get posted, and so I didn't see it till after Quaternion's. But we're not going to quibble about that. We're going to say that we have 2 co-champions, 2 grand champions, 2 co-regents, if you will, Charlotte and Quaternion. Good job to both of you. Okay, now let me jump in and talk about what was the assignment. The assignment and the grand challenge was to create, and that is askew, you must straighten that up, to create a binary up-down counter. So let me get out of your way. So you were to have 2 buttons and 4 LEDs. This is to be the increment button. As you press it, you are to count up in binary and display those on the LED, and the red button is a countdown button, and so this will decrement the total, this will increment the total, and the total will be showed on the LEDs. Now the circuit is the one we've been using in the last few lessons. This rightmost LED, the long leg, is connected to GPIO pin 16, and then this one, the long pin, is GPIO pin 17. This one, the long pin, is GPIO pin 18. This one, GPIO pin 19. The short legs are connected. The short legs are connected to 300 through 330 ohm resistors to the ground rail, and the ground rail is established over here on our physical pin 38. Then with physical pin 36, we create a power rail. Now on the 2 buttons, the rightmost button is the red button. It's the decrement button, and it is connected to GPIO pin 14. The leftmost button, the green button, which is the increment button, is connected to GPIO pin 15. So our in base is referenced to, its 2 pins referenced to GPIO pin 14, and our out base is 4 GPIO pins referenced from GPIO pin 16. Okay, hopefully you guys, that makes sense. We've used this for the last few weeks, so I don't want to spend any more time talking about it. But what I would like to do is kind of talk to you about the strategy. The first thing you can see is with 2 buttons, you can't do the nice easy thing of interacting with a pen just by waiting for it to change, because we have 2, so we have to be watching 2 at once. So we're going to have to read the 2 buttons using the in command, which will bring their state into the ISR. So with the in command, if we have a 0, 0, that means neither one has pressed. If we have a 0, 1, that means we want to decrement. And if we have a 1, 0, that means that we want to increment. So what do we do if I read a 0, 0? What do I want to do? I want to read again. If I have a 0, 1, what do I want to do? I want to decrement. If I read a 1, 0, what do I want to do? I want to increment. So those are the sort of 3 blocks in our program. Now, sitting and doing a read, that's pretty easy. If you don't have anything, just loop and read again. But if you read a 1, 0, you are going to have to increment. Now, the good news is decrementing is really easy because we have that Y deck, right? We have that Y deck and we have that X deck as part of our jump, one of the parameters in jump. And so that actually makes it pretty easy. The trick is for us to figure out how to increment, because there is no X increment, there is no Y increment, so we've got to trick this into incrementing. Okay, so how are we going to do that? Let's come over to the sketch pad and let's just think about what would be easy. It would be easy to decrement. So let's just look at that. So if I had a 0, 1, 1, 1, and if I wanted to decrement that, that would go to what? 0, 1, 1, 0. That would be easy. If I wanted to decrement again, I would go to 0, 1, 0, 1, like that. Okay, here, what are we doing? We are decrementing, okay? But now the question comes up, what would we do? What would we do if we wanted to? What would we do if we wanted to increment? Okay, so let's just say I wanted to increment this one. Well, there's 3 things you do to increment. The first step is you invert, okay? And I've showed you how to invert before, so you invert it. So what would that be? The 0, 1, 1, 0 would become 1, 0, 0, 1. Okay. Now, after you do that, number 2, what you do is you decrement. So then if I decrement this, what is this going to be? 1, 0, 0, 0. And then the third thing you do is you invert again. Okay. And inverting would make this 0, 1, 1, 1, like that. Okay, now let's look at this. If I go from here to here, what did I do? I incremented, okay? Does that make sense? Hopefully that makes sense. But you see, as you're dealing with state machines, you've really got to go down there and you've got to think about the 0s and 1s, because you just have such a tiny number of commands that you've got to squeeze out as much functionality from that few number of commands as you can. And so this is the basic strategy. Okay, so what am I going to do? I'm going to read. If it's a 0, 0, I'm going to read again. If it is a 0, 1, if it is a 0, 1, am I doing that right? 0, 1. Let's come over here. And I want to make sure that I'm saying that right as I'm saying it. Okay. So if it is a 1, 0, what do I want to do? I want to, if it is a 1, 0, I want to increment. If it is a 0, 1, I want to decrement, okay? And if it's a 0, 0, I want to read again. And remember that this is pin 15, and this is pin 14. Okay, hopefully that makes sense. So with all of that said, I think we need to jump in and start coding this thing. And so it's going to take a couple of lines of code to get this set up. And so let me come over here. I'm not going to put that view in there for right now. We'll come back to that in a minute. We will come back to that in a minute. So what do I need to do here? I need to do a little desktop management. Okay. All right, so what am I going to do? First thing is, from machine, I am going to import pin. Why? Because we're going to have to set up those input pins. We're going to import RP2. Why? Because we're going to be using the state machine. Now we're going to create our decorator, which is at rp2.asm. What are we doing here? We are putting MicroPython on notice. We are putting MicroPython on notice. This is quite sensitive. We're putting MicroPython on notice that there's incoming machine code. So ASM_PIO. You guys should be comfortable with this because we do this every week, but I'm going to set my out init. I'm going to init my output pins to what? RP2 the library.pio programmable input output out low. So I'm going to start with all of those GPIO pins low, and I put that awkward dangling comma, and then I say do that for 4 pins because I have 4 output pins. Then I've got to tell it the out shift dir is going to be rp2.pio.shift right. And I've explained this in a lot of the earlier videos, so I don't talk a lot about it. We kind of do this every time, so you should be getting comfortable with it like that. Okay, out init pr2 pio out low times 4 out shifter rp2. Okay, that looks pretty good. Now we've got to define our function. So what is my function going to be? My function is going to be inc deck like that. Inc deck like that. Okay, now we're going to go ahead and make our wrap target like that, and then we're going to do a wrap like that. Okay, so I'm just going to call that function for now. I'll come back and fix that later, but I just want to kind of get the bookkeeping of the program done so I don't forget it. Now we have those 2 input pins, pin 14 I need to define, and that is going to be a pin. Which pin? Pin 14, and it is going to be a pin dot in, and then we need to activate the pull up resistor. So I'll say, or pull down resistor, pin dot pull down, and I've explained this in the last few lessons, so you guys should understand this. Then I also have pin 14 or pin 15 is equal to pin 15 comma pin dot in, activate the pull down resistor. Why? Because we didn't put an external one, so we have to turn on the internal one, and that is all uppercase. And this should be all uppercase here. Like that. Okay, now we need to instantiate our machine. We'll call it state machine 0, and that is going to be rp2 the library.state machine. We're going to use state machine 0, and then I am going to say that what is our function? Our function is going to be inc deck that we just set up. The in pin base, we're going to go from pin what? We're going to go from what pin? We are going to go from pin 14. Okay, and that pin 14 we set up here. So it's referencing then the actual GPIO pin 14. So in base is 14. That's good. and then we're going to use a frequency of 2000, and then the out base is going to be equal to the the pin 16. So our output pins are going to be all relative to pin 16, GPIO pin 16. So that's 16, 17, 18, 19. Why? Because we said there was 4 pins up here. So you guys, hopefully this all makes sense. And then what we are going to want to do is we're going to want to come in and say SM0. We're going to activate it. So we say active state is 1, so that will turn it on. Now we've got to come in and we've got to actually write our machine code. And it's really pretty easy since we've already sketched it out. It should be pretty straightforward. Now the first thing I want to do is initiate my counter. I'm going to have the Y register be my counter. Now, every once in a while, we're going to need that Y register. And we're going to have to move our active count out and do something with Y and then bring our active count back into Y. But basically, as much as possible, we're going to keep our active count in the Y register. So I'm going to go ahead and before I start, I'm going to initialize that. And so what I will do is I will say set Y to 0B0000. So all the LEDs initially are low, and that corresponds to a binary number 0000. So our code is in sync with where our lights are over there, our LED. Then we have our wrap target. Now what I'm going to do is I'm going to label this point in the code. I'm going to label this point in the code, but read. So this is where I am going to read the buttons. Okay. Now what I want to do is I want to clear my ISR register because I'm going to read into it. And you typically shift data in, so I want to start with it empty so I don't end up with extraneous bits in there. So what I'm going to do is I'm going to move into ISR null, and that will clear my input shift register. Now I'm going to do my read. So I'm going to say in. Where am I going to shift my data in from? From the pins. And then what am I going to shift in? What am I going to shift in? I am going to shift in 2 bits. Now, why 2 bits? Why 2 bits? I'll come over here and show this now. Why 2 bits? Because I have 2 buttons. And the first one is 14 and 15, so it's going to read pin 14 and pin 15. It's going to read these 2 buttons. We are cruising right along here. We are cruising right along. Okay. So now that is the butt read. So now we have read the 2 pins. We have read the 2 pins in to the ISR, and then we want to move to X register what is in the ISR. Now, why do I have to move it to X? Because I want to compare 2 numbers, and the only way I can compare 2 numbers is to compare X and to compare Y. So I have to have one number of interest in X and the other number of interest in Y. So I've got to kind of move things around in the register, so I'm using a register that can do the thing that I want it to. So ISR allows me to shift in. Once it's shifted in, I'm going to move it to X. So now it is in X. Now, what if I'm going to jump, and if there is nothing in X, then I'm going to go back to but read. Okay. Now remember, X is going to have the 2 bits, the left button and the right button, right? It's going to have the green and the red button is going to be read in. And if both of those are 0, that means there is nothing in X. Then what do I want to do? I want to read again. So I'm going to just sit here and I'm going to be looping until one of these buttons is pressed. Now, hopefully that will make sense. So I'm going to read again if there is nothing in X. So that is good. Now, at this point, we have to decide. At this point, if we get to this point in the code, what does that mean? One of the buttons has been pressed. Now we have to decide which button was pressed. Now I'm going to need that Y register. that Y register has got my active count, but I need that for something else now. So what am I going to have to do? I'm going to have to move to the OSR what was in. I'm going to have to move into OSR what had been in Y, because I got to use Y for something else. So I'm going to hold my active count in OSR. Now I'm going to set Y to 0B0001. So what would 0B0001 be? That would be like a Y button press. That would be like a red button press. Okay, that would be like I had requested a decrement. Okay, I had requested a decrement. If I get a 0001, I have requested a decrement. But remember, our logic is backwards, so I am going to jump if X is not Y. Okay, now why do I do, and where am I going to jump? I am going to jump to increment, like that. Okay. So I've captured the read values. If the read value is not 0001, what does that mean? That means if the read value is not 0001, that means it must be 0010, which would be the increment button. And so what will I want to do in that case? I would want to jump to increment. Okay, I would want to jump to increment. And in fact, I should probably come down here and label my increment. So later on, I'll have to come down here and deal with label, okay, increment, like that. So if I press the increment button, I want to jump down here to this part of the code. But otherwise, if I end up at this line of code, what does it mean? It means that the decrement had been pressed. It means that the decrement had been pressed. Well, what do I want to do if the decrement is pressed? I want a decrement. But what I've got to remember is I ended up here because this button was pushed. Okay, the decrement button was pushed. And if I just jump in and do my next command, I've created a loop where it's just going to loop and it's going to decrement, 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 decrement. So if I get to this point, I need to wait here until I take my finger off the button. Otherwise, it's just going to be sitting there decrement counting as long as I have my finger on the button. If you don't believe me, leave this command out and see how well it works. So what do I want to do? I want to wait until I get a 0 on pin 0. So when I press the button down, I'll have a 1. Why is this pin 0? This is pin 0 because this is pin 14 and the end base was set to 14. So then the relative 0 would go to pin 14. So I get here and I have to wait until I let my finger off the button. And then once I let my finger off the button, I've got to go get my active count again. So I'm going to move back to Y, OSR. What did I put in OSR? I had to use Y for something else, so I put my active count in OSR. Now I'm going to get my active count from OSR and put it back in Y. Okay, I'm going to get my OSR and put it back in Y. Now I want to decrement Y. So how do I do that? Well, I'll do a jump. And with that jump, I'll do a Y decrement. And then where am I going to jump? I'll just say jump to NXT. And then I'll just label this NXT. And so what does this do? This does not look happy. Like that. Okay, what does this do? This doesn't do anything but decrement Y, which is our active count. All right. Now, what do I want to do? I have decremented my counter. Now I want to move that counter. I want to move that counter to Y. I want to move Y to the pins. Right. So now that active count, I want to move that out to the LED. Okay. Now at this point, what do I need to do? I need to jump back up. I've done everything I need to decrement the counter and display it. So now I need to go back and read again. So I'll just go back up to the top to but read. Okay. And this is the decrement, right? And so I think I'm going to go ahead and run this and see if we have some errors in here. Okay, line 27 right off the bat. What is that not like? So inc dec is inc dec, right? Int dec. In base is equal to. You guys tell me what I did wrong. State machine 0. Indec in base is equal to pin 14, comma, frequency equals the old equal sign there. So now let's run it and see what happens. Okay, PR2 is not defined in line 3. Okay, RP2. Shift direct RP2. RP. Rookie mistake. Hopefully you guys saw that. Okay, now this button's not going to work, but let's see if this button works. Look at that. Okay, you see I've got half the program written. I'm decrement counting. It's kind of the easy half, but I do have that. And then if I come here, you see I don't have that weight in there, so it's just kind of going crazy because I haven't programmed that part of the code yet. So now what do I need to do? I need to come down here. And now I need to do the increment part of it. So what do we need to do with the increment part of it? That was that little trick that I sketched out for you. So what do we need to do? The first thing we need to do is we need to wait for a 0 on pin 1. Okay. Now why is that? This is pin 1. And if I don't put that in there, it's just going to be running through the code like this. It's going to be just running through the code like crazy like this, okay? So I need to wait. And what was this? Pin 1, and I'm waiting for the finger to be released so that it doesn't just go in circles. Now, what were the steps that I need to do? Well, remember my active count had been moved to OSR, so I need to move back to Y, OSR. So now my active count is in Y. Now I need to move Y to Y. I need to invert Y. So what have I done? I've now inverted Y. So what did I say the steps were? You invert Y, you decrement Y, and then you invert Y. And that will result into an increment. So I need to invert Y. So that is done. Now I need to decrement Y, so I'm just going to say jump to, and when I jump, I'm going to do a Y decrement. So this is going to decrement, and then I'm just going to jump to next to, like that. And then this is going to be label NXT2. So all this does here is this just decrements. This just decrements Y. And now what do I need to do? I inverted, I decremented, now I need to invert again. So I'm going to say move to Y, invert Y. So I'm doing that second invert. And now what do? I move Y. I move to the pins Y. Like that. Okay, so I invert, I decrement, I invert. That turns into be an increment, and now I move that incremented Y value to the pins, and now I am ready to rep. Could it really be that easy? Let's come over here, let's run it and see. Okay, no errors, everything's 0. Let's come up to our larger view, Everyone hold their breath, and we are going to try to see if we can increment. Boom! Binary counter incremented. And you see, look, I'm going to hold it down. Nothing happens until I release. 2, 3. Now watch the magic happen. 3, 2, 1. 0. 0 minus 1 would be go back to 15, 14, 13, 12. 13, 14, 15. Go to 0, 1, 2, 3, 4. 5, 6, 7. Boom. Okay, guys. Anyway, that was the grand challenge. So really kind of the magic on this thing of how to make this work is, and what I really wanted you to see is really kind of what we are used to is when we want to do something, we find the command to do it. And so naturally in Python, you would just look, if you were in Python, you would look for the increment command. And then if you couldn't find an increment command, then you would see if there was a library to increment. And then if you couldn't find a library to increment, you would search and see if somebody had solved this problem before. But on something like this state machine, it's new enough. There's no solutions that are out there. You got to kind of figure it out on your own. And how did you have to figure out? Well, it's easy to decrement, but if you're going to increment, you're going to invert, you're going to decrement, and then you're going to invert, and that will result in an increment. So hopefully that makes sense. Okay, guys, hopefully you are having as much fun taking this class as I am making it. I'm not going to give you a homework assignment. The homework assignment is, if you haven't gotten this to work, to go ahead after watching me do it and get it to work. And now I think what I would like to do next, I can't say for sure, but I think probably what I'd like to do next is now that we're comfortable with those different commands, inputs and outputs and all those different things, now that you're comfortable with it, what I would like to do is I would like to go in and start hooking up some hardware where you can see where the really state machine shines and where the state machine does things that you can't do just with the normal MicroPython. Okay, so I've sort of taught you most of the fundamentals of how the state machine works. And now what I want to do is I want to go in and show you some real world examples where you really need that state machine to solve them. Okay, guys, I want to give a shout out to all of you who are supporting me on Patreon. The way that I'm able to stay in the game these days is through your support. Some of the other things aren't going so well. It's you Patreon guys that keep these classes coming, and I want to thank you for that. You can help me by giving me a thumbs up on the video or leaving a comment down below. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later. There's a swimmer. You see the swimmer? Look at that. That's amazing. We have a man overboard. Do you think he's supposed to be in that boat? What's he going to do? Most of you guys already turned it off. You're missing the most important part of the show here. Look at that. Wow, jumped right into the boat. Now he's probably either a co-fisherman or perhaps we're watching a hijacking in place. But nonetheless, anyway, appreciate you guys. I will hope to see you next week. Paul McWhorter with TopTechBoy.com signing off.